Welcome, ladies and gentlemen, here in the forum of our group exhibit, Hydrogen Fuel Cells and Batteries. Welcome to the next talk here in the forum. Here on the group exhibit, it's all about commercialization. So we want to bring fuel cells to market, especially stationary fuel cells, and that's what the next talk will be about. We will talk about commercialization, stationary fuel cells in Europe, a study of the fuel cells and hydrogen joint undertaking. And I'm very happy to have here with me on stage the consultant, civil economics, energy and infrastructure, Markus Kaufmann from Roland Berger Strategy Consulting GmbH. Mr. Kaufmann, be very welcome here.
Thanks for having me. Thanks.
Please have a seat, and all of you are invited to ask your question. If you have any question, just raise your hand. I'll be with the microphone right with you. Well, Mr. Kaufmann, it's good to have someone from Roland Berger here on stage, actually, because that means business is becoming serious in that branch, isn't it?
Well, yeah, certainly. I think you could say so. At least our company has been dealing with fuel cells for quite a year, for quite some time, and we've published a range of material on the industry. But it's the first time really that we have focused on the stationary branch of the industry, which we really think is at a critical stage at this point.
You made this study during 1 year. That was the work of 1 year.
That's a lot of book. Yeah.
Brain in it, obviously.
Yeah.
Okay, that's the book. You can still have it at the booth of the Fuel Cell and Hydrogen Joint Undertaking, and that's what we're talking about. So they asked you to do it. Can you tell me a little bit about the FCH JU?
Sure. So, I mean, I invite all of you to show up at their booth and talk to them in person. But the FCH JU is basically a public-private partnership among the European Commission and the fuel cells and hydrogen industry, as well as a number of research organizations, associations, and other bodies. And they basically have a mandate to support research and product development in hydrogen and fuel cell industries, so to say. And in their capacity with funds from the Commission, they mandated a study. In this case, we were given the mandate to perform a study on the topic of commercializing stationary fuel cells, together with a coalition of 35 organizations from the fuel cells and hydrogen industry in Europe.
So that's very good. So you have a public-private partnership. You can ask the partners, how far are you? How serious is it? And you get the data from them, which is very interesting for the study in the end. But if you think about stationary fuel cells, could mean a lot of things. They are the micro CHPs for house heat. They are fuel cells for distributed power. They are and heat generation. They are megawatt scale solutions for the industry. So what did you concentrate on?
Well, when we first started the discussion, we had a coalition, a very diverse coalition of 35 different organizations and companies. We had some big names like Weiland and Wiesmann from the sort of traditional heating industry. We had big energy companies, and we also had a lot of fuel cell companies, many of them who are still in a sort of startup stage, and who are all focusing on diverse things. So we had to cut the market in a couple of segments. And so we concentrated on 3 of them, basically. We concentrated on residential applications for basically for 1-2 family homes, which are the so-called fuel cell micro CHPs. Then we had a second segment where we looked at apartment buildings and commercial buildings. So that is anything from schools to offices or even hospitals, shopping centers.
We're talking megawatt 2 to 5.
Talking a power range of starting with 5 kilowatt for apartment buildings that have a central heating system, and going up to 400 kilowatt electrical power range for the commercial applications. And then you have a big chunk, which is what we call the industrial application, where it's not so much about providing heat and power to a building, but it's really about an industrial application that requires a more bespoke solution. So these residential, commercial, and industrial were the 3 segments that we focused on.
And they're quite different, but they have one thing in common, because they are very efficient. All of them are very efficient. Even if we stick to fossil fuels in our energy supply, we can use these fossil fuels much more efficient than before if we burn it.
That's exactly. I mean, that's essentially what we looked on. We found that distributed generation, meaning that you produce energy at the point of its use and of its consumption is still quite a foreign concept, actually, unless you're talking about renewables. And so we looked at these applications really as something that is disruptive to the market. That you don't only have, when you heat your home, you don't only take the power from the grid and you burn gas in a boiler, but that you have an intelligent energy unit in your house that can do the same thing at both things at the same time, and does this, let's say, for an average case of a German one-to-family home, about 24-25% more efficiently than your standard solution, gas plus grid.
And that's the one advantage. And the other advantage is we have a certain situation, especially in Europe, especially in Germany, with renewable energies. We have a lot of renewable energy sources. We are capturing ever-larging shares of power generation, and since they are volatile, you have to do something with it. If there's a lot of wind, if there's a lot of sun.
Yeah, that's a really good question, because that looks at the whole industry from a more systemic perspective. We're asking the questions: what role can fuel cells play in the larger context of the changing landscape of energy supply in Europe? And here, yes, the fact of the matter is that fuel cells are a controllable generation unit, and that's the main difference to renewables. Burning natural gas, eventually also biogas, eventually hydrogen, makes them comparatively carbon efficient, and still you have control. So for instance, you can offset or sort of complement, if you want, renewable energy supply from solar and wind. Whenever there's too much of that, you sort of run down the fuel cells a little bit, and if there's not enough of that, you basically speed up the generation.
Especially for peak times, you can use big fuel cells they have high efficiency, and they also can be modulated quite flexibly. That's a big advantage, I think, about a fuel cell. It's a grid that needs balancing, needs a device that is modulated quite easily.
That's correct. So if you think, for instance, in comparison with standard generators, with your internal combustion engines, sort of technical performance at modulation of down to 50% is significantly stronger. Now, what we have to see, however, in practice, is how you can capitalize on these benefits. So what we need is larger scale demonstration projects where a larger number of units are deployed at the same time, functioning as a virtual power plant or something, in order to show that from a systemic point of view, this can make sense in terms of complementing renewables. Here, it's important to say that the industry is at a very early stage, but nevertheless, this is something that is a very promising case and also business model, we think, that should be explored further in demonstration projects.
But Mr. Kaufmann, I have always learned, you need hydrogen for a fuel cell. So where does the hydrogen come from?
Well, I think that's the main difference, and maybe that's also a little bit of a reason why stationary fuel cells have not grasped that much attention in the past. The systems that we focused on, 90% of them run on natural gas. Which means that they have a reformer on site that sort of generates the hydrogen, so to say, of a certain purity on site. But the key advantage is that supplying hydrogen is not an issue. So we don't have to think about large-scale hydrogen supply. These systems can capitalize on the existing natural gas infrastructure in Europe. And now, if you're thinking markets like Germany, especially like UK or Netherlands, where we have an excellent system and gas distribution network in place, this is a key advantage in terms of going into the market. So what we're targeting really is the entire market, for instance, in the residential segment of gas homes, and that market is quite significant.
Do you think we are talking about capacity markets here in Germany sometimes? This could help also fuel cells to get into the market as a capacity power supply? Well,
let's say sort of as a capacity supply or operating reserve, we're really more talking about the systemic level again, because the largest fuel cell park deployed today is a 60 plus megawatt in South Korea, which is an exception really. So at the smaller units, which are closer to commercialization at this point, it would require quite a substantial number of units at the same time in order, for instance, in Germany to qualify for capacity markets or operating reserves. I think for the industry, it's more important right now to focus on convincing the customer and getting them into the market.
So if we talk about commercialization of these devices, they need one thing: they need to become less costly. They're still too expensive. That's the big problem about stationary fuel cells.
Yeah, and that's essentially the main finding of the study, which is not a huge surprise, but at least with the primary data we had from industry players, we were able to put a number on the price gap that we see right now. And yes, I mean, essentially they're very efficient, which means that in terms of running energy costs for a household, you can have a very promising business case, because when you, for instance, have a heat-driven micro CHP, you produce a lot of electricity. Some of them in Europe, some of that can be fed into the grid, and you get compensated for. So, in terms of operating expenditure, the business case is the best you have. The problem is your capex. So the investment as a homeowner to put the fuel cell in your basement. And here, price ranges between 30 and 40,000 euros per micro CHP is just way too much in a system where you can have an all-in gas condensing boiler for 5,000 euros.
Where do you see the potential for micro CHP in Europe? How many devices could be sold?
Well, that's an interesting question. Talking again about the fact that we can address the entire more or less, let's say, gas-based or gas-heated one or two family houses in Europe, the market is quite substantial. I mean, we're talking about more than 800,000 units in total in Germany as a total market that could be addressed. And only a fraction of that, of course, would already help the industry quite significantly. If you take, for instance, the 4 key markets that we analyzed in the study, which is Germany, UK, Italy, and Poland, the total addressable market per year is 2.5 million units.
That's a lot.
That's
a huge
also,
market.
That's a huge target. That's also including a lot of houses that still use different heating, let's say oil, or in Eastern Europe even coal-based. But the market is there. The potential is there. Now we have to talk about what needs to happen in order to get to market shares like first 5-10%, where innovative heating solutions like heat pumps are today.
If you want to sell them, it's only the customer who will buy them and will pay for them, and he looks at the total cost of ownership. And if it's too high, it's probably what is needed, some funding to make it competitive.
Yeah, so like I said, at current price ranges, between, let's say, 30 or 40,000, that's the price range that we took in the study. We're not really talking commercialization yet at this point. So I think if we can reduce the capex for the customer by about 40 to 50%, which is ambitious, but which the industry thinks is doable, then we see already a sort of competitive positioning where fuel cells perform quite well compared with other high-end heating solutions. That is heat pumps, that is engine-based CHP. So this is really the first step, getting into volumes of 500 to 1,000 units per manufacturer, where prices can come down about 40-50%, and you can start to make a commercial proposition to the customer. And for that, yes, it's inevitable that the industry needs some startup support.
But can you understand the decision makers in politics who say, well, we support already decades for demonstration projects, not again more money to that technology?
Yeah, and that's a fair question that we also looked at into the study. So what we recommend is essentially a pact, so to say, between the industry and policymakers. So the industry needs to make very strong commitments that costs will come down, that technical performance will be sustained and improved further. Here we're talking efficiency, we're talking durability, we're talking the robustness of the system. And if these things are sort of, if these commitments are achieved, then I think the political side should help to get really this industry one final step further. That's the opinion, because the benefits are there. We save primary energy, we save a lot of emissions, CO2, pollutants, etc. So the technology has quite some potential, also from a public policy point of view. But now we have to come to a point where we translate our good technologies into real products in the market, into a real chance in the market. So that's the final step. And here I think we have to say, if the industry can keep its commitments, it's good. But if it cannot, then we do not propose to put up a new EEG law like in Germany, where we fund this thing forever.
So, Mr. Kaufmann, I understand it correctly. You're asking for a market introduction programs for the micro CHP if the industry keeps its declarations. But what about this medium-sized, medium-range fuel cells CHP? What do you think? What they need?
The picture is more diverse here, really. I mean the products, especially the CHP applications for the commercial segment, are at a much earlier stage in the product life cycle, especially in terms of the European companies. So they require more research and development for prototyping and also demonstration projects. So in this sense, the industry is more diverse than, let's say, on the mobility or transport side. But these products are not there yet, so to say, for market introduction. So
isn't it easy just to scale them up, the small ones to scale them up?
Yes, absolutely. In principle, yes. And on the supply side, when you talk on the stacks, that's certainly possible. However, the commercial market segment and the industrial market segment functions completely differently. You have different market actors. You have a much tougher business case, so to say, because the power prices, the gas that you're competing with are lower. So here you also have to find new sort of innovative propositions for customers, contracting models, leasing models, cooperations with energy companies in order to get these products into the market. But like I said, first of all, we don't really have products yet in these segments. So we need
some demonstration.
We need some R&D. We need some demo projects to show that technically this segment can fly. And after that, we can talk about market introduction.
What about the industrial applications? They are on market already. They are in Japan and United States. They could come to market right away. What do they need?
Well, in the industrial segment, once again, the picture is a little diverse. We have some strong performance, and we got the big names in the US like Bloom Energy, Fuel Cell Energy Solutions, for instance. We've got big projects in Asia as well. In Europe, we don't have that strong of a European manufacturer's base as we have for the micro CHP. So here some catching up needs to happen, but the companies that are ready, what they need project-based business. So if also here market introduction is necessary, we also have a price gap. So what you would require here is project-based support. The challenge is for the industrial segment that it's not about standardization, because you don't sell the same unit to everyone. You have usually bespoke solutions that you tailor to the needs of the customer. So in this sense, you have to talk about modular concepts, for instance, in order to bring costs down. And here, some more project-based business would certainly help.
Are there any questions from the audience? Just raise your hand if there is one. Well, my last question is, we are now in the commercialization phase, as you pointed out. How long will that take? What do you think?
Well, ultimately, it's not so much a question of time. I think it's a question of volume for the manufacturers, right, and how they can succeed in sustaining performance.
So when will we have the volume of 2.5 million in Europe?
Well, that would mean essentially conquering the entire market. So I would say that's gonna take a while. Let's focus. What we say is focus on the next 3 years, 3 to 5 years, to get these products off the ground, get them from field tests and demonstration projects into a first commercialization phase, so that customers can get into ranges of 1,000 up to 5,000 units. And this is where we're going to have to see the costs come down. Otherwise, it's going to be tough to sustain in the long run.
Thank you very much, Mr. Kaufmann, for this interesting talk. And I would like you to also stay here, because we are proceeding with a panel discussion, which is now going on here about micro CHP fuel cells roadmap for market launch. Your host will be Alexander Dauensteiner, Head of Technology Portfolio Development of Weiland Group, and he has 4 interesting partners here on stage. So we will closely follow this panel discussion. We just prepare the stage and start right away. Thank you once again, Mr. Kaufmann, for this speech here. Thank you for your attention.
Thanks, everyone. Get a copy. Yeah.